This video is going to be about the product property of logs. According to the product property, if you have two logs added together and they have the same base, which is very important, you are able to write them as a single log by multiplying, in this case, 3 and 72. So notice the base is 6 in both of them. If I did not have a base of 6 in both of these logs, I could not do this. But because they have matching bases, I'm able to use the product property. So the way the product property works is I'm going to take these logs and write them as a single log by multiplying 3 times 72. When you combine them into a single log, the base is still 6. Okay, don't add, don't multiply, anything with your bases. Keep the bases the same. All I've done is multiply the 3 and the 72. And now I can evaluate this log. In a previous video, I showed you how to do this by converting to exponential form. So because I don't know what this is equal to, I'm going to say that it equals x, and then I'm going to find x, and that's my answer. When you convert from log to exponential form, the base of the log, which is 6, moves to the other side and becomes the base of the exponent, which is x. Now it's just a matter of figuring out 6 to what power is equal to 216. So you're going to be better off if you know a lot of these numbers in your head. You can always use a calculator to guess and check. But eventually, hopefully, you come to the conclusion that 6 to the third power is equal to 216, which means x would be 3. So after using the product property to write this as a single log, I have evaluated the log and found that it equals 3. Here's another problem where I can use the product property. I've got two logs added together and they have the same base. In this case, the base is 1/3, and it's totally fine that I have a fraction as a base. As long as they match, I can do the product property. According to the product property, I can multiply the 27 times 1/9. If you're not super comfortable with multiplying, put the 27 over 1 so that you have two fractions multiplied together. Now you multiply straight across. That gives you 27 over 9, and that equals 3. So when you multiply 27 times 1/9, you end up with 3. I still have a base of 1/3, you don't change it. And now I need to figure out what this log is equal to. Just like the previous problem, I'm going to set it equal to x and convert this to exponential form. So the 1/3 was the base of the log. Now it's going to be the base of the exponent of x. And I'm writing it in a different order as last time just to show you that it doesn't matter which one is on which side. I'm trying to figure out how to go from 1/3 to 3. I have a video where I demonstrate what happens when you have a negative exponent. Hopefully you get to a point where you recognize that if you are going from a fraction to a whole number or a whole number to a fraction, that means your exponent must have been a negative number. So if I'm going from 1/3 to 3, I know that this was flipped. The base was flipped, meaning I found the reciprocal. So I'm really focused just on the denominator. The denominator is 3. I want to know how 3 became 3. Well, 3 to the first power would be 3. But in order for it to flip, it would have to be 3 to the negative first power. So I'll write that out to the side. I have 1/3 to the negative 1. Now, if I apply the negative exponent only, or just the negative sign from the exponent, that 1/3 becomes 3/1. Once you apply the negative exponent, the exponent is now a positive 1. Now it's just 3/1 to the first power, which is equal to 3, which is what we wanted to do. So to go from 1/3 to 3, 1/3 would be raised to the negative 1 power.